Video we are going to discuss about the IC engine, that is internal combustion engine. Myself, I am Rajakumar, assistant professor, Department of Mechanical Engineering, Rohini College of Engineering and Technology. Internal combustion engine is nothing but IC engine. That means combustion take place within working fluid of the engine. Thus fluid get contaminated with combustion product. Petrol engine is an example of internal combustion engine where the working fluid is a mixture of air and fuel. And then external combustion engine. The working fluid get energy using boilers by burning fossil fuels or any other fuel. Thus the working fluid does not come in contact with combustion product. Steam engine is the example of external combustion engine where the working fluid is steam. Then this is the classification of IC engine. Commonly first basic from heat engine. Heat engine is classified into IC engine and EC engine. Again we are classify the IC engine, rotary engine and reciprocating engine. Rotary engine is again classified into open cycle gas turbine and wagon engine. Reciprocating engine classified into petrol engine and diesel engine. Then classification of IC engine. So internal combustion engine may be classified into following ways, that is according to the type of fuel: petrol engine, diesel engine, gas engine. According to the method of ignition: spark ignition engine, combustion ignition engine. According to the number of strokes: 4-stroke engine and 2-stroke engine. Then according to the cycle of operation: Otto cycle, diesel cycle and dual cycle engines. Then this is the component of IC engine. The major component of IC engine is the piston and cylinder. So cylinder, then cylinder head and crankshaft. So piston and crankshaft are connecting by connecting rod. Then piston pin and exhaust valve, inlet valve and spark plug. These are the component of the basic components of IC engine. Then next we are going to see the working principle of the IC engine. Majorly, basically we are 4-stroke engine and 2-stroke engine, in which the 4-stroke engine having the petrol engine and diesel engine. Same 2-stroke engine having classified into 2-stroke petrol engine and 2-stroke diesel engine. Here first of all we are going to see the 4-stroke petrol engine or 4-stroke SA engine. The figure, you can see this figure. In the first figure indicate the suction stroke, second figure indicate the compression stroke, third figure indicate power stroke, fourth figure indicate the exhaust stroke. In which we are going to, first of all we are going to see the working principles of the 4-stroke petrol engine or spark ignition engine. In the 4-stroke engine, the cycle of operation is completed in 4-stroke of the piston or 2 revolution of crankshaft. During the 4-stroke, there are 5 events to be completed: suction, compression, power and exhaust. Then each stroke consists of 180 degree of crankshaft rotation, and hence the 4-stroke cycle is completed through 180 of crank rotation. The cycle of operation for an ideal 4-stroke SA engine consists of the following strokes: suction, compression, power, exhaust. The detail of the various processes of the 4-stroke spark ignition engine with the overhead valves. You can see this image, the 4 images there, in which the first image, there is a suction or intake stroke, in which the piston, when the piston is at the top dead center and about to move to downwards, the inlet valve is assumed to open instantaneously, and at the time the exhaust valve is in the closed position. Due to the suction created by the motion of the piston towards the bottom dead center, the charges consisting of fuel air mixture is drawn into the cylinder. When the piston reaches the bottom dead center, the suction stroke end and the inlet valve close instantaneously. Then compression stroke, next figure indicate the compression stroke. That time the charge taken into the cylinder during the suction stroke is compressed by the return stroke of the piston. During this stroke, both the inlet and exhaust valves are in the closed position. The mixture which fills the entire cylinder volume is now compressed into clearance volume. At the end of the compression stroke, the mixture is ignited with the help of the spark plug located on the cylinder head. In expansion stroke, that time the high pressure of the burned gases forced the piston towards the BDC. Both the valves are in closed position of the force stroke only. During this stroke, power is produced both pressure and temperature decrease during expansion. Then finally, the last exhaust stroke. Last figure shows the indicate the exhaust stroke. That time, the end of the expansion stroke, the exhaust valve open instantaneously and the inlet valve remains closed. The pressure falls to atmospheric level. A part of burned gases escape. The piston start moving from the bottom dead center to top dead center and the sweep the burned gases out from the cylinder almost at atmospheric pressure. The exhaust valve closes when the piston reaches TDC. Thus, for one complete cycle, there is only one power stroke while the crankshaft makes 2 revolutions. For getting higher output from the engine, the heat addition should be high as possible. The heat rejection should be small as possible. Again, one should be careful in the drawing of the PV diagrams. Okay, the 4-stroke, this is the working principle of 4-stroke petrol engine. Then next we are going to see the working principle of 4-stroke diesel engine or 4-stroke CA engine, that is compression ignition engine. Is similar to 4-stroke SI engine, but it operates at much higher compression ratio. The compression ratio of an SI engine is between 6 and 10, while for CA engine it is from 16 to 20. In the CA engine, during suction stroke, air inside of the fuel air mixture is induced. Due to higher compression ratio employed, the temperature at the end of the compression stroke is sufficiently high to self-ignite the fuel which is injected into the combustion chamber. In CA engine, the high pressure fuel pump and injector are provided to inject the fuel into combustion chamber. The carburetor and the ignition system necessary in the SA engine are not required in the CA engine. Then this is the basic of the 4-stroke CA engine. In first suction stroke, that time the piston move from TDC to BDC. Air alone is induced during the suction stroke. During this stroke, inlet valve is open and exhaust valve is closed. Then compression stroke, in this stroke, the piston move from PDC to TDC. Air induced during the suction stroke is compressed into the cylinder clearance volume. Both valves remains closed during this stroke. Then expansion stroke time, the fuel injection stroke nearly at the end of the compression stroke. The rate of injection is such that combustion maintain the pressure constant in spite of the piston movement, and this expansion stroke increases and the volume heat is assumed to have to be added at constant pressure. Then last figure shows indicate the exhaust stroke. The piston traveling from PDC to DDC pushes out the product of combustion. The exhaust valve is open and the intake valve is closed during this stroke. Due to this higher pressure in the cycle of operation, the CA engine has to be stronger than a SI engine for the same output. This result is an CA engine being behavior than the SI engine. However, it has a higher thermal efficiency on account of higher compression ratio. About 18 as again about the 8 in SI engine used. Next, we are going to see the 2-stroke petrol engine. 2-stroke engine is a type of reciprocating engine that uses only 2 stroke of the piston is completely a power cycle. The 2-stroke engine complete one revolution of the crankshaft after the completion of the 2 piston stroke. Then the 2-stroke engine works in such a way that the intake and compression process are completed in the first stroke of the piston. The power and exhaust process are completed in the second stroke of the piston. Thermal efficiency of the 2-stroke engine is depend on the design and model of the vehicle, but generally a 2-stroke petrol engine only convert 20% of chemical power into mechanical work. Only 15% of this energy is used to drive the vehicle, while remaining 5% of energy lost to resist the friction and other. The figures indicate the 2-stroke petrol engine. In the first figure indicate the suction and compression, and second figure indicate the power and exhaust. In 2-stroke engine, the cycle is completed in one revolution of the crankshaft. The main difference between the 2-stroke and 4-stroke engine is that method of filling the fresh charge and removing the burnt gases from the engine. The 4-stroke engine these operations are performed by the engine, piston during the suction and exhaust stroke respectively. The two-stroke engine, the filling process is accomplished by the charge compressed in crankcase or by a blower. The induction of the compressed charge move out of the product combustion through the exhaust port. Therefore, no separate piston strokes are required for these two operations. Next in this, two strokes are sufficiently to complete the cycle. The one for compressing the fresh charge and the other for expansion or power stroke. It is to be noted that the effective stroke is reduced. The figures shows one of the simplest two-stroke engine, crankcase scavenging engine. The air fuel charge is induced into crankcase to the spring loaded into valve when the pressure in the crankcase is reduced due to the upward motion of the piston during the compression stroke. After the compression and ignition, expansion take place in the usual way. During the expansion stroke, the charge in the crankcase is compressed. Near the end of the expansion stroke, the piston uncovers the exhaust port and the cylinder pressure dropped to atmospheric pressure at the combustion product leave the cylinder. The piston top usually has a projection to deflect the fresh charge towards the top of the cylinder, preventing the flow through the exhaust port. This serves the double purpose of scavenging combustion product from the upper part of the cylinder and preventing the fresh charge from flowing out directly through the exhaust port. This is the working principles of two-stroke petrol engine. Next, difference between the four-stroke and two-stroke. Four-stroke engine, one cycle completed in every 2 revolution of crankshaft. Here, one cycle completed in every evolution of crankshaft. Then more moving parts is there. Here, two-stroke engine less moving part. Four-stroke engine more maintenance charge. Whereas here less maintenance. The four-stroke engine having heavy in weight, but here light in weight. More expansive four-stroke engine, but two-stroke engine less expansive. Next, we are going to see the difference between the two-stroke cycle and four-stroke cycle. Two-stroke cycle is a lightweight engine, but four-stroke heavy weight. Then two-stroke engine operate in many position, but four-stroke engine operate in limited position. But two-stroke engine high power to weight ratio, but here low power to weight ratio. Engine oil usually mixed with the fuel, but here engine oil is the reservoir. Well, louder operation, but two-stroke slower operation speed. Well, four-stroke engine higher engine speed, but here smoother operation. Then difference between the petrol engine and diesel engine. So petrol engine working in the Otto cycle principle, the diesel engine working in the diesel engine. Diesel cycle working in the diesel engine working in the diesel cycle principle. Here petrol engine air fuel mixture suction stroke. Only air is sucked during the suction stroke. Spark plug is needed, but here in the diesel engine no spark plug needed. Compression ratio 6 to 12, but here diesel engine compression ratio 14 to 22. Then lower efficiency in petrol engine, but diesel engine high efficiency engine, but petrol engine lightweight engine, diesel engine heavyweight engine, but petrol engine less vibration and noise, but diesel engine high vibration. Thank you.